to Deeksha Online. Today we are going to discuss few objective questions from the topics atomic structure, chemical bonding and periodic classification of elements. Now the first question, in multi-electron atom, which of the following orbitals described by the three quantum numbers will have same energy in the absence of magnetic as well as electric fields? Which of the following orbitals have same energies? So energies can be found by the values of n and then L. So if at all n plus L value, if n plus L value is same, then we can say the energy of orbitals are same. Let us take the options one by one. If we take the first option, the value of n is 1 and then L is 0. Means here the value of n plus L is 1. When you take the second one here, the value of n is 2, value of L is 0, therefore the value is equal to 2. If you take the third one here, value of this is n is equal to 2, n is equal to 2, L is equal to 1 we have, therefore n plus L value is 3 we have. If you take the fourth one, n value is 3, L value is 2, therefore the value is equal to 5. And finally in the fifth one, n value is equal to 3 and then L value is equal to 2. Again same thing we have, the value is equal to 5. So in then fourth and fifth cases, values of n plus L are same. That implies those two orbitals will be having same amount of energy. So energy of the orbitals is decided by n plus L values. Therefore, option is D in this case. Option is D we have. Then, next one. For a principal quantum number n is equal to 4, total number of orbitals having L value 3. Total number of orbitals having L value 3. L value 3, that implies, so L value 3 means it is F sublevel. L value 3 means it is F sublevel. Because L is equal to 0, L is equal to 0 will be S sublevel, L is equal to 1 will be P, L is 0 is S sublevel, L is equal to 1 it is P sublevel, L is equal to 2 is D sublevel. They gave L is equal to 3, it is F sublevel. And F sublevel contains 7 orbitals in that. F sublevel has 7 orbitals. Therefore, answer is option B we have. Then, next one. So, that is B option here. Third one, the following quantum numbers are possible for how many orbitals? They are given the quantum numbers. We have to see for how many orbitals these values exist. Now, n value is equal to 3, L value is equal to 2. When you say L value 2 here, that comes for D sublevel. So we have D sublevel. And then for D sublevel, we have altogether 5 values of M. So M is equal to plus 2. So therefore actually M values will be minus 2, it is minus 1, 0, plus 1 and then plus 2. These are the 5 values of the M which indicate the 5 orbitals, and they are given as value of M is equal to plus 2. Therefore it indicates only one orbital. Therefore when M is equal to plus 2, it indicates only one orbital. So answer is A. So here the answer is A now. Then the wave number of the first emission line in the atomic spectrum of hydrogen in Balmer series. It is a first emission line, that too in the Balmer series we have. The Rydberg's equation nu bar is given by R into, it is 1 by n1 square minus 1 by en2 square we have. When it comes to Balmer series, the value of n1 is equal to 2. For Balmer series, n1 is equal to 2, and then when you say first emission line, the value of n2 is equal to 3. So for Balmer series, n1 is 2, for first line n2 is equal to 3. Substituting values here, which is equal to R into it is 1 by 4 minus 1 by 9, which is equal to R into it will be 5 by 36. So the answer is 5R by 36 we have. So option is D. So Rydberg's equation is R into 1 by n1 square minus 1 by n2 square, and for Balmer series value of n1 is equal to 2, and for first emission line the value of n2 is equal to 3. Substituting these values we get 5R by 36. So answer is option D we have. Option D. Next one. The ionization energy of hydrogen atom is 13.6 electron volts. What will be the ionization energy of the helium? Now, the first ionization energy, that is ionization energy of He plus is equal to 13.6 into Z square, where Z is a atomic number or number of protons, which is equal to 13.6 into Z is equal to 2 for helium, Z square is equal to 4. Therefore, the value is equal to 54.4. So many electron volts. This will be ionization energy of helium. So option is B option. So the formula of ionization energy is equal to 13.6 into Z square. Z is equal to atomic number of the unielectronic species. That is, Z is equal to 2, 2 square is 4, 13.6 into 4, so 54.4 we have. So answer is 54.4, that is option B we have. Then, which of the following is correct order of the size in the iodine species? The order of the size. When you take anion size will be always larger than neutral atom, and cation size will be always smaller than the neutral atom, because anion is being formed by addition of electrons and cations are being formed by removal of electrons. So therefore finally the order of size, anion will be larger when compared to neutral atom, that is going to be larger when compared to cation. So option is D we have. So option D is the answer in this case. So option D we have. Then comes seventh one. The isoelectronic with CO. The ion with isoelectronic. Isoelectronic word stands for having same number of electrons. Let us see the electrons present in CO first. CO means atomic number of carbon is 6, plus that of oxygen is 8. Therefore, we have here 14 electrons in CO. Now, coming towards O2 minus. O2 means we have 16 electrons here. O2 minus is present. O2 minus is present here. Therefore, add one more electron for that. It comes out to be 17 then now. O2 minus means. Then N2 plus. N2 will have 14 electrons. N2 plus will have 13 electrons in that, because we are removing an electron from that. O2 plus will have, O2 is having 16 electrons here. O2 plus will have only 15 electrons then now. So O2 is having 16 and O2 plus will have 15 electrons here. Cn minus carbon, that is Cn minus carbon has 6 electrons, nitrogen has 7 electrons, minus charge is there, plus one more extra electron. Therefore, total number is 14 here now. Hence, the CO has 14 electrons and Cn minus is also having 14 electrons. Hence, the CO is isoelectronic with Cn minus. Hence, option is D. So, simply we are writing here the atomic numbers. If they have a charge minus, adding electrons. If they have a charge plus, removing electrons. In that way, we can find out the number of electrons in the given species. So, answer is option D we have. Then comes eighth one. Which of the following is going to have maximum number of unpaired d electrons? Maximum number of unpaired d electrons. In the case of d block elements, we need to remove electrons first from s orbital, then followed by d orbitals. Let us take the option A first. So, for a zinc atom, atomic number is 30 and therefore configuration is 4s2, 3d10 we have. Now when you take Zn plus 2, remove electrons from s orbital. Zn plus 2 is having 3d10 then now. This is the option A we have. When it comes to option B, Fe plus 3. Now Fe atomic number is 26. 26 means it will be 4s2 3d6 we have. And Fe plus 3, remove 3 electrons, that is 2 from S and then 1 from D, hence it will be 3d5. Then the option C, Fe plus 2. Fe plus 2 means remove 2 electrons from S, therefore it will be 3d6. And option D, chromium. Chromium atomic number is 24, therefore configuration is 4s1 3d5 for chromium, and Cr is plus 2 state, remove 2 electrons, that is going to be 3d4. Now question is maximum number of unpaired d electrons. So d5 will have maximum number of unpaired electrons here. So therefore answer is Fe plus 3. So in d orbitals or d block elements, we need to understand that electrons are removed first of all from s orbital, then only it should be followed by d orbitals. So answer is option B we have. Then next one, which of the following oxides is not expected to react with sodium hydroxide? So sodium hydroxide nature is base, so it can't react with any other base, it can react only with the amphoteric and acetic oxides. If you see these options, BeO is amphoteric in nature, B2O3 is a non-metallic oxide, it is acidic nature, and SiO2 is also acidic in nature. Only CaO is coming under metallic oxide, which is also basic in nature. Since both of them are the same nature, this is not expected to react with calcium oxide. With the remaining three here, the sodium hydroxide can react. Therefore, answer is option C we have. So option C is the answer here. Next, hydrogen bond is stronger in. The strength of the hydrogen bond depends upon the electronegativity of the atom attached to hydrogen. Among these four options given to us, we have fluorine here. Fluorine is having higher electronegativity when compared to oxygen or sulfur or nitrogen here, and therefore this will be option C will be having stronger hydrogen bond. So option C because of higher electronegativity of the fluorine. So answer is option C. Then which of the following has highest ionic character? Highest ionic character. If you observe the options, all have same anions, that is Cl minus anions. So now we need to see the cations then. So whichever cation is larger in size, that is going to always have more ionic character. Therefore, Na plus Cs plus is there here, K plus and Li plus. So Cs plus ion will be larger in size among all these four cations. Therefore, CsCl is going to have highest ionic character. So when all cations are same, we need to see, when all anions are same, we need to see the size of the cation. So larger size cation is going to have always higher ionic character. Therefore, option is B in this case now. So that is a CsCl is the answer. Then the shape of ammonium ion is. The shape of any ion depends upon hybridization as well as followed by number of lone pairs and then bond pairs present in that. So now when you take ammonium ion structure, that is to say ammonia NH3 and then ammonium ion, so it is going to form a coordinate covalent bond with hydrogen. So therefore finally we have here 4 bond pairs are present and 0 lone pairs. When a molecule has 4 bond pairs and 0 lone pairs, there will not be any distortion in the structure. Therefore, the structure is going to be tetrahedral because of 4 bond pairs. 4 bond pairs stands for tetrahedral structure. So answer is option B in this case now. Then number and the types of bonds present between the carbon atoms in calcium carbide. So calcium carbide structure is, we can say right like this, Ca, it is going to be C2, that is there are triple bond between these two, or else it will be Ca plus 2 and then carbon atoms like this we have. This implies here between the two carbon atoms of calcium carbide, if there are triple bond is present. Triple bond implies there should be one sigma bond and remaining two of them are pi bonds. Hence it will be one sigma bond and then two pi bonds. So option is C in this case. One sigma and two pi bonds are there. So option C we have. Then the correct order of bond angles among the following molecules. The molecules given are ammonia, PCl3 and BCl3. The bond angles depend upon the number of lone pairs, bond pairs as well as the hybridization of these molecules. Now when you consider BCl3, boron is undergoing sp2 hybridization and there are no lone pairs on that. Therefore, the angle is going to be 120 degrees. When you take the ammonia as well as PCl3 molecule, central atoms are undergoing sp3 hybridization. But ammonia molecule has one lone pair whereas PCl3 molecule is having two lone pairs now. When you have one lone pair, the angle gets reduced from tetrahedral angle. Two lone pairs, the angle gets further reduced. An angle in ammonia is 107 degrees and therefore PCl3 has even lesser than 107 degrees. Therefore, the option is BCl3 has 120 degrees, ammonia has 107 and PCl3 has even less than 107 because it is having two lone pair of electrons. Therefore, answer is option B we have. So depends upon hybridization as well as number of lone pairs and bond pairs. Which of the following is paramagnetic in nature? Which of the following is paramagnetic in nature? When you take O2 minus ion here, it is having one unpaired electron. It has one unpaired electron. Therefore, that is according to MOT theory. It is a one unpaired electron means nothing but it is paramagnetic in nature. If you see Cn minus ion, that is Cn minus, carbon 6 electrons plus nitrogen 7 plus one more we have. Altogether we have here 14 electrons here. If you take CO, that is here 6 plus 8, which is also we have 14 electrons there now. When you take NO plus, that is 7 plus 8, but electron is removed here, minus 1 electron, which is equal to 14. All have the even number of electrons. Therefore, they are completely paired up. Hence, they are diamagnetic in nature. Therefore, O2 minus is going to be paramagnetic. So, answer is option A.